Okay, recording started. So first, I'd like to talk about a couple of plans for the next half of semester. First, today today is week number 7. So week number 7, we're going to cover this topic, chapter 5. And the next week, we will do one more chapter, chapter 6. That's week number 8. After week number 8, we will have a brief stop right here. We will have our midterm exam. So midterm exam will be after we finish all the sensors. After the midterm, we will start with chapter 7. We'll talk about the actuators, the final control element, like the auger Craig is talking about, the motors. And then we will talk about the controllers. We'll talk about analog computers, mechanical controllers. And the last chapter will be the tuning of a PID controller. So ultimately, my goal for this class is for everybody to be able to get some kind of experience on PID controller. Different part of a PID control. PID means proportional integral derivative. So that's 3 mathematical functions used as a controller in the controller to make a decision what to do to make our process under control. And that is most used controller in the industry. And so we will do this week one chapter, next week one chapter, then we will have midterm. The midterm will not use our class time. The midterm will be on I will post it on Canvas on the 8th week. You guys, I will give you guys I haven't decided, maybe 1 day or 2 days to finish it. Or a couple hours, maybe a couple hours would be a good idea. So I will post the midterm exam online and give you a time frame for you to accomplish that midterm exam.
So wait, you said we'll have a few days to do that?
No, I've not decided. Let's talk about next week. I will look at the Canvas, how I set up the exam. Not a few days. Maybe I will put out a timer. For example, 2 hours for you guys to work on it. Whatever time you start, give you 2 hours once you start working on it. At least my first exam on Canvas, so I will let more detail next week. But anyway, it will be at least the 7th week. The test will be on next week. I will have more detail next time we meet during the lab session. So that's the lecture part. We will have a midterm exam. The lab part, I also decided what we're going to do. Obviously, we will keep having demos through Zoom meeting. After the demos with Zoom meetings, like we said, ultimately we want to get some experience on the PID controller. And that's really what we're going to do. We want everybody to do a PID controller. So on the screen I'm sharing you right now, this is the PID controller everybody need to purchase. It will be PID controller. The model number is 106RL. 106RL. So this will be it, 106RL, $26 with free shipping. Well, you need to buy this, and then you need to buy a temperature sensor, K sensor. That's the K sensor right there. But this controller does not came with the K thermocouple sensor. So that's another $7, $8 K sensor. Make sure when you check out, you add that K sensor.
So
yes.
So I'll go here, and did you say there was something I could click to add the heat sensor to the package?
Yeah, the same seller also has K sensor. Yeah, you go to their seller store.
Okay.
Seller store. Yeah, seller. Yeah, that's right. I just did this weekend myself. It works really well. The PLD process, you will learn so much. I would think this is better than any semester's lab because previous semester we really wasn't able to have everybody have a PLD controller and set it up and tuning it and work on it, change all the parameters, and watch how the controller, the whole system responds. Also, you can change the power supply. This one, the power supply will be AC or DC, 12 to 24 watts. So it's a pretty wide variety of power supplies. What I did, I want to highlight it, and it's just turn dark. All right. Yeah, AC, DC. It doesn't matter it's AC or DC, as long as it's 12 to 24 watts. Let me show you mine. I point my camera over to this.
Oh, excuse me. What seller? What's the name of the seller?
I don't know. Just search Google PID controller 106 RL.
The seller, it looks like, is Inkbird. If you click right under the name of the item, right above where it has the ratings, you can go to that specific seller store.
Inkbird is the brand, yeah. Well, we will talk about that later. Let me show you what I did. It's over there. Basically, I have two boxes. I have two boxes. The bigger box is in the outside, and then I have a smaller box inside. And the smaller box inside has a 60 watts light bulb. And also the temperature sensor is inside. And then the controller is inside the bigger box. And then I mounted the controller over here. I mounted the controller right here. Did you see the controller?
Yep.
Yeah, I see it.
Yeah. So by having the controller over here, right now, if you see it, I have it set at 73.6. Right now is Right now is a 70.
73.5.
Yeah, 5. Yes. So it's a 0.1 degree away from my set point right now. So it's still working to get the that 0.1 degree difference. So now you know why we need a PID controller. It's really accurate control. You can really get that temperature, in this case, 0.0 degree and close. So in the industrial setting, for example, Craig was talking about he just reprogrammed his PLD. It's a programmable logic controller. The same thing can be done again automatically. That's manual control because what you did? Can you tell everybody what you did, Craig?
I work at St. Joseph Plastics, and our plastics flow rate was too low, so I put in a chemical called peroxide, which breaks up the polymer compounds. But anyway, I had this PID controller that allowed me to change the flow of the peroxide chemical into the new plastic melt.
Yeah,
so
that's excellent. So what did you change?
I changed the settings that I changed the settings so that it went up from about 0.88% peroxide to 0.98% peroxide. A very small difference, but just enough to change the flow rate of the plastic.
Excellent. That is based on your experiment, right? You added extra and then measure the flow rate. Add a little bit extra, measure the flow rate.
Yeah.
And then finally decided this is good. So this is a manual control. So you control the how much peroxide you said added.
Yeah.
What we were talking here is automatic control. So the PID controller is automatic control. So basically, in your line of work, it will be, I want my flow rate to be this and this, and then this sensor will measure the flow rate in real time, and my controller will change the percentage of that chemical, how much is added. So the flow rate will be automatically correct all the time. So that's the automatic process control. That's another way to get the job done.
That'd be really convenient.
Yes, don't mess up. Otherwise, you get tons of plastic not working. Yeah. So PID control is really a good controller, and I hope with this PID temperature controller, everybody will change parameters, and everybody will gain some experience and be confident. You know, when you'll be able to tune a PID controller, you really can get a lot of job opportunities, because that's being used everywhere in the industry to accurately control the process automatically. All right, great. That's what our plan will be next. So we will use maybe 5 weeks for everybody to work on this PID controller. The reason I use RL is it's a low voltage version. So you need a power supply. It can be AC or DC power supply. I just cut open laptop charger. That's pretty good. That's the connector goes to the laptop. I can't even find that laptop anymore. I don't know where the laptop is, but I have this power supply. I have a couple of those actually. So I cut it open, and those will be 20 watts DC. So that's an excellent power supply. Provide 60 watts. Excellent. The one I'm using right now is a transformer. It will be those 24 watts transformer. You might have a couple of those around in your house. 24 volts AC transformer. You can also use a PC power supply. If you have an old personal computer, desktop, you're not using anymore, I have a couple of those in my basement. If you you have to pay somebody like $10 to haul it away. Nobody wants those. But that power supply you can take out and use it as a DC power supply. It's actually a very good DC power supply, like 100 watts.
So what you're saying is we got to cut off the end of the power supply and just stabilize it and put it onto the PID temperature controller?
Yeah, provide power for the heater, provide power for the controller, yes.
Okay.
Or if you really don't want to do any of those, you can have a car battery. That's 12 volts DC power supply.
Mm-hmm.
You have a car battery, lawnmower battery, golf cart battery, whatever you have. This will work, but obviously don't want to use this because we are talking about heating something. This probably lasts a couple hours. Don't use this. It's 9. If you use 2, you will have 18 watts. This will. So
is there a power supply on Amazon that you would tell us to buy? Because I don't think I have any of that stuff.
You can also buy a power supply like $10, $20. They call the DC power supply. Yeah.
Okay.
Yeah, that's another choice. Thank you, Tim. That's another. If you have another $20, $10, yeah. So anything about that before we start chapter 5?
So I don't have this cord with me. I'm in the same boat. So what type of power supplies do we need to look up and purchase?
Power supply, let me, I never thought about that because Tim mentioned that. Let's do a search. Yeah, previous semester we did other projects actually buy those power supplies. I remember like $10, $20. DC power supply. Don't buy those. Those are too expensive. 90s. Those are really good, but expensive.
There's a $15 one.
Which one?
That you passed.
Okay. This one? This one is not enough power. We need about ideally 60 watts, 30 watts. This one is 300 watts, so that's really powerful DC power supply.
Okay.
Let me change a little bit. Sorry, this is better. Get a little bit better. This is actually pretty good. You can change voltage to 48 all the way. Yeah. This is what I'm talking about. But I would change my mind. Don't buy this because you are dealing with wiring 120. The 120 actually, the bare copper is goes here. In this lab, I really want to be safe. So if you go that, buy one of these. Buy this, not this. Buy this like $39. Not this. Yeah. You need to buy a DC power supply if you don't want to make it one yourself. $9. Why not buy one of those? $9. Yeah, these will work.
Okay.
But you need to cut the wire here also.
Okay.
Or you need to or buy a plug. Yeah. Yeah, they have a plug here.
Can I just, I don't know, cannibalize something like this? Or does it have to be DC power?
AC, DC, all works. What is this?
All right.
What you are holding on?
Oh, just some cord.
Like a phone charger?
Yeah. Well, this is actually an old cord for an electric razor. So, yeah.
Make sure it has plenty of voltage, like 20.
Okay. Let me let's see. Okay, how many volts did I need?
20.
It says that the output is 15 volts and 5.4 watts.
Yeah, the wattage is a little bit low, but it may work. Yeah, you can try that.
It might work. Okay, I can try it.
Right now, my power supply is 20, draw 200 milliwatts, milliamps.
For the wattage rating, it just needs to be above 60. It can be anything above 60.
Right now, I'm actually using only 5 watts. But it's really painful. I need a powerful, bigger light bulb. I would really like it to be, you know, that little box I'm heating. 5 watts is not enough heat. I really need 20. I want 20 watts. I'm using a 60 watts light bulb. I'm looking for a 100 watts light bulb. 100 watt light bulb. A 100 watt light bulb, if you power it with 20 watts power supply, it will provide 10 watts maybe.
Okay.
I will have, I'm working on instruction. I will put a Word document about power supply, about controller, about everything.
Okay.
You guys have questions and some instructions. It's very simple to wire. And all you need is 2 boxes. A small box is the warm box. The bigger box is all the devices. So you have a nice clean PID controller to work on. I'm looking at my PID controller now is 73.6, perfectly controlled. So it has been like this for some time. My room temperature probably right now is 60 something, 68. So it's a couple degrees above because my heating element is really only 5 watts. Not very powerful. After this class, I'm putting another 60 watts light bulb if I cannot find a 100 watts light bulb. I really like to find 100 watt light bulb. I don't have it anywhere. You probably divide the wattage in 10 by 10. You get an estimate of actual wattage if you power it with 20 volts power supply. So the light bulb we designed for 120, but the voltage I'm using is 20. So the power is about 10%. 10%. Of the actual power. All right.
What page are you on?
Huh?
Oh, I said what page are you on?
The textbook.
Oh, yeah.
223.
Okay.
All right. Let's really get started.
I posted a link in the chat because I think I found one that'll work good, and you can adjust it too.
Very good. Very good. Yeah.
It's $18.
$15. Great. How many watts?
It says max is 72.
Okay. Yeah, that should be ideal for our.
9 volts to 24 volts DC, max wattage 72, 3 amps,
Okay.
and it's adjustable.
Yeah. The controller need 24, maximum 24. So that's perfect. So you get 24 volts to the controller, and then 24 volts to the light bulb, provide the heating. So we will talk about the mechanical sensors today. We will cover 4 categories of mechanical sensors.
Can you change your camera? It's showing your Amazon.
Oh yes. Let's make my camera bigger, right?
Perfect.
So now, the first category will be motion, location, position sensors. So if you want to control anything like a robot motion, you need to find the locations. So you can just have a PID controller, for example, control the location. If you want to do, for example, 3D printing or a lot of mechanical devices. So how do you control location? Number one is wiper. This is the sensor. Our local company, Gray Manufacturing, they use this sensor to measure the location of the height of their car jet. So it's a very simple sensor. Mechanically, you have a wiper. The wiper will move up and down mechanically by the rotations. So you can actually, or just left and right motion. So the wiper will move left and right, and that wiper will contact these resistors. The resistor is made of some kind of metal conductors. So the resistance, for example, from the terminal 1 and 2 will be fixed. For example, it's 10 ohm. And then the wiper will move up and down. The resistance between 1 and 3 will change, or 2 and 3 will change. So that's a very simple sensor. To illustrate That's your sensor. So this is your resistor, and that's your wiper. The wiper will move up and down, and the resistance here will change. Right? Resistance between those two will change. Because the resistance from the top and bottom will never change. But because the motion on your wiper, the resistance between the wiper and the bottom terminal will change. So by measuring resistance, we can measure the position. So this is the first type of position sensor. The second type of position sensor are capacitors or inductors. So those are the type of sensor also developed in the 50s, even before 50s, during the Second World War. They invented those because they want to detect metal detectors. If you have a mine in the field, you want to find those with a metal detector, and that metal detector looked like this. And it turned out the closer the, for example, this piece of iron goes into the coil, the larger the inductance. So basically, by measuring the inductance, you can measure the position of this target. So that's inductive. Also, we can have a capacitive sensor. The capacitive sensor looks like left and right. The left, the sensor moves horizontally. The right, the sensor moves vertically, the motion, measure vertical motion. It all works the same principle. Horizontal motion will change the capacitance. The vertical motion on one plate will also change the capacitance. So again, by measuring the capacitance, we are measuring positions. So out of those two basic principles came a industrial standard sensor, most commonly used position sensor called LVDT. LVDT is a linear variable differential transformer. So LVDT is a transformer. Make it first and most, it's a transformer. What is a transformer? It has a primary coil. It has a secondary coil. So that's a transformer. And how can we use a transformer to measure position? It's a specially designed transformer. So this is a transformer. So that's an AC power supply. That's the primary coil. And then we have a secondary coil. Notice that we have two identical secondary coils. One wired from left to right, the other goes from right to left. So these two, say, for example, if the primary coil is 120, the secondary is 10 here, the second secondary will be negative 10. So what is the output? Output will be 0. So we have 120 primary, 10 secondary, negative 10 secondary. The subtraction will get 0. So that's the transformer. 2 secondary, the output is 0. What happens when the core, we have a movable core. Previously, the core is not moving. What happens if we move the core left or right? If we move our core material to the left, what happens is more energy will go that direction. More energy will go to that direction because we're moving the core in that direction. So now the secondary, number 1 secondary will be 12. Number 2 secondary will be 8. The voltage will be 8 here, 12 here. So you will have a positive voltage coming out because 12 subtract 8 is a 4. So you have positive. So the far away the core material moves toward that direction, the more positive it goes. Similarly, we can move opposite direction. by moving opposite direction, the output voltage will be negative, because now the secondary 2 will have more higher voltages. That's negative. The positive is smaller voltages. You do a subtraction, you will have negative. So this is how this sensor works. And this sensor turned out to be extremely accurate. How accurate? It's up to 1/1000th of an inch. 1/1000th of an inch. So it's used to control, for example, a paper mill. If you are making papers, you are measuring the thickness of your paper, and that sensor will measure how thick. So if I want my paper to be 1/1000th of an inch thick, and so 1 inch, I will have 1,000 pages. That's how thin my paper will be. And that sensor can be used to measure. So if the paper is too thin, it will tell the controller. Or otherwise, if the paper is a little bit thicker than required. So this sensor is extremely sensitive. That's number one. And number two, this sensor is extremely tough. It works in extremely tough environment. It can handle moisture, can handle dirt, can handle mechanical vibrations. So that's perfect choice in the commercial setting, because if you want to put this sensor in a very tough environment, and it will survive. Some other sensors may not be able to survive, but this sensor is really, number one, is accurate and sensitive. Number two, it's very tough. How about the cost? Cost, unfortunately, is very high also. This type of sensor with the circuit, because it's so accurate, there is a digital circuit attached to it. The accuracy came from the digital, high-frequency digital circuit. So generally, it will start with a couple $100. Let me do a Google search so you can get an idea how much this sensor cost. So that's the sensor cost. It's 200, 100. Oh, this one is good, 300. So this sensor kind of expensive, but in the industry, this couple $100 is not a problem. Oh, we have one over here, $17. This one is $1,000. So this the price is a huge difference. So in an education setting, we might just be okay, have this $20 ones. We might do not have the accuracy or do not have the sensitivity, but
you see that one that was like 1,500?
Yeah, that's right. That's
Gee, that one better be like really accurate, like down to like 10,000th or something.
Yes, that's right. That's why it's, yeah. Did you read the manual, the data book? Yeah. I lost it. Yeah, $1,500. I saw that. Yeah. Yeah, this one is $1,100. So basically, it's a transformer. Inside, it's just a primary coil, secondary coil. This sensor, the tip, this sensor is the core attached to the core material. So whatever the sensor moves, the core material moves. So that's the core. That's the sensor, the moving part. The core will move up and down, and the output will be positive, negative voltages. So that's the second type. The first type is a variable resistor. The second type is a capacitive or inductive type. The third type are called the level sensors. Those are also very common in the commercial applications because we are talking about the tanks, cooking vessels holding raw material. So we want to make sure the tank is not empty or not too much material, will not overflow or not empty again. So there are many different types of level sensors. This one is mechanical. It's like a toilet type. The toilet is a perfect example of this mechanical sensor. This one is electrical. Your gas tank. You're filling gas in your gas tank. That's the sensor. This one is electrical. This is ultrasound. So you basically like a radar, ultrasound transmitter, a receiver. The sound travels almost 300 yards per second. So by measuring the echo, so you have an echo. By measuring the echo in this direction or this direction. So both way works. This ultrasound travels below the surface of material. This is above. Either way, you can use ultrasound to measure the level. We will have a demo this week, ultrasound. The last way, we can use a pressure sensor to measure the tank level. That makes perfect sense because the higher the water level, the more pressure you can measure at the bottom of your tank. That way, you measure the level of your tank indirectly by measuring the pressure at the bottom of your tank. For example, about 30 feet of water equal to 15 psi. 30 feet water equal to 15 psi. That's a rough estimate. 30 feet of water, 15 psi. So what happens if you have 1 feet of water? How much pressure will create 1 feet of water? 0.5 psi. So that gives you an idea. By measuring psi's, the pressure, you can find how much water is inside the tank. So if your psi is 2 psi, you probably have 4 feet of water inside. That is only for water. If you change the material, oil is a little bit lighter than water, so the psi's will be a little bit smaller. The oils, alcohol is also gas is lighter than water, gas. So which is heavier than water? Salt water is heavier, yeah. Anyway, that's our first type of sensors. We covered the three types. So number one, position. We have a resistor type, capacitor type, inductor type. Then we have a level sensor. The number two sensor is called the strain sensors. Strain sensor is also extremely popular. For example, you go to the gym, and every time I go to the gym, I walk right to that scale, right? I want to see my hard work actually have some progress. So I always want to try to measure the weight. So when you go to the scale to measure the weight, there is a strain sensor. If it's electrical, it will be electrical strain sensor. Otherwise, there will be a mechanical strain sensor. So this is a electrical strain sensor. Electrical strain sensor. What we have here is conductors. We have a very long conductor wire. It's so long, so we just have a loop it back and forth, back and forth. What happens if you pull the sensor that direction? If you provide the strength, provide the force, pull the sensor in that direction, this is elastic. The sensor will become longer, get longer. When the sensor gets longer, the conductors became longer also. When the conductor became longer, the resistance will go up. Remember? The resistance equal to, everybody remember that equation. Resistance equal to, right? That's the equation to calculate resistance. So this L is the length of your resistance, length of the wire. If you some way make your wire longer, you double the length, you will double the resistance. That is if the area doesn't change. But in reality, when you double the length of this wire, the area will also halve. So if you double the length, the area will be half, the resistance will be 4 times, right? In this case. So the resistance will change with this direction. This is called the sensitive direction. So this direction is sensitive. The vertical direction will be insensitive. So because you basically doesn't change the length of the wire that much. So you have a sensitive and non-sensitive direction. Typically, we put two together. Why we put two together? One is called active, the other called dummy. The dummy is insensitive. You notice the active is one direction, the dummy is a vertical direction. So the dummy is inactive. So the reason we put the dummy there is to cancel the temperature effect. Remember, these are also temperature sensors. What's the name of this temperature sensor? We just learned RTD sensor. So this long wire is also a RTD temperature sensor. And you really don't want your sensor, strain sensor, also measure temperature. That will be noise. That will be like you go to the gym in the summer, you weigh 200 pounds. You go to the gym in the winter, you weigh 150 pounds. It's not because you lose 150 pounds. It's because your sensor is messed up by temperature. So obviously you want the dummy to cancel the temperature effect. Usually the dummy is put it right here. That will be your dummy. That will be your active. That whatever temperature active effect on active will have the same effect on the dummy. So the temperature will cancel. The only thing changes the resistance will affecting the reading will be the strain of this sensor. So this is called a stressed member. The stressed member is two sensors with one active, one dummy. By having a dummy, we cancel the temperature effects of this sensor. So it will only measure stress, only measure strain. Another example is we not only we put two, we actually put four together. We call cantilever beam. We put four together to make it more sensitive. So we have two active, two dummy. They will be all identical. So the active and dummy are identical. They made identical. The only difference is the dummy is in the inactive directions. The active sensor is in the active angle. With this sensor, all four resistors of this bridge will be sensors. So this will be dummy number one, dummy number two, active number one, active number two. And using this sensor, because we already have four resistors, the bridge, we do not need any external resistor. So we just wired it like a bridge, and the output sensitivity will be doubled. Why the sensitivity will double? Because if you look at this will measure the beam, support beam. So if in the construction, they can put this sensor on a support beam. It will measure the deflections of your beam. So if the beam is bent downward, active one will increase resistance, active two will decrease resistance because the strain direction will be opposite of the two sensors. So that way you double the sensitivity of this sensor. So that's number one, strain gauge. Number two strain gauge is called semiconductor strain gauges. This is more common. Most of those scales you measure your weight is using these types of electrical ones. So this is a semiconductor strain gauge. The semiconductor strain gauge is a semiconductor chip. They build a semiconductor chip right on as a sensor. So when there is a load on top, the resistance will change. It is the semiconductor gauge, strain gauge are very sensitive. Unlike the previous ones, is the resistance change is only 0.1% or 0.2% of resistance changes. This one can have, for example, 10%, 5% of resistance changes when with the strain. So this is more sensitive. But we have a problem with this type of sensor. It's nonlinear. So the resistance change significantly, but it's not linear. It's like this. For example, it's not linear. And that problem can be solved by digital circuits. So today's digital circuits are so complicated. Everything, we can put thousands of components right here and make very complicated calculations of filtering or DSPs. So not a problem, although this nonlinear problem can be solved by digital signal conditioning. The signal conditioning, digital signal conditioning generally refers to a computer algorithm. The computer will recalculate based on your input, and if it's nonlinear, and the computer can convert it to a linear output. So it's very complicated on one side, but it's extremely simple to the user. The temperature sensor I demoed last week is one of those examples. So it's 10 milliwatts per degree, So the output is extremely easy for the consumers. But that temperature sensor is a semiconductor. Again, just like the semiconductor strain gauge, it's non-linear. But no problem, we can make that linear, and the output is perfect linear. So that's our second type, strain sensor. The third type will be the motion sensors. Motion sensors, again, is very common consumer electronics. We have motion sensors around our house, multiple. I have probably 10. So those external lights will turn on once they detect motion. So these motion sensors are generally the type use a security system are infrared motion sensors. We will have a demo for the motion sensor, infrared type motion sensor, but we will also have a demo for a digital type motion sensor. The digital type motion sensor, most common is called accelerometers. Accelerometer measure acceleration. So that's what the sensor does. It will measure how fast you accelerate. There are many different types of accelerometers. We can have this type number 1. This is a position sensor. Remember this position sensor? LVDT, linear variable differential transformer. And then if there is a motion right here, that motion or acceleration will be picked up by this sensor. So this is one type. The other type can be a variable reluctance type. Can be piezoelectric type. There are so many. The one we're going to demo is actually a hot air chamber type. So the accelerometer we're going to demo is a hot air chamber. So they have a heater here. Heater. The heater will be energized. So we will have a hot vapor inside this chamber. And then we have temperature sensors at the 4 corners of this chamber. We have 4 temperature sensors. So if this sensor is perfectly level, all 4 temperature readings will be identical. If this sensor is tilted, one sensor will get hotter, the other will get colder. So the one we're going to demo is this type of sensor. So there are many different types. This is 2-dimensional. So it will measure X and Y tilt, tilt in X and tilt in Y angle. It will also measure acceleration by measuring how fast the temperature changes. So acceleration is done by how fast the temperature. All right, that's another type. The last type will be pressure sensors. This is one of those pressure sensors. Notice that this pressure sensor also uses LVDT, the position sensor. So we are measuring the position of this bellows very accurately. When the pressure increase and decrease, it will create motion because the P2, it will measure the pressure differences. So this sensor will measure the pressure different. So we have one is P2, one is P. So if they are identical, this sensor will not move. There's no motion. So if we increase the pressure, the sensor will move left. Increase the P1, the sensor move right. So by measuring the position, we indirectly measure the pressure. This is one of those sensors measure pressure. That's another type of sensors. This is those pressure gauges. That's the most popular pressure gauge you buy. I have a couple of those. Also, the pressure gauge on the compressors. If you have one of those compressors, 100 psi, 200 psi, 50 psi, how do you read the psi's? That's the meter. So this meter is a tube that is bended. But when you increase the pressure here from, for example, 0 psi to 100 psi, the tube will tend to get straight. When tube have a tendency, when the pressure increases, the tube will want to get straighter. This will indicate the pressure. That's how the readout came from. It's called a burden tube. So this tube will measure pressure. Of course, this is only for human to read out. If you want the electrical instrument to measure the sensor, you probably will measure the position again. So again, you have to indirectly, by measuring the position of the end of your tube, you get the indirectly measure the pressure of your sensor. If you have one of those electric tire gauge, right now it's very common. So my old tire gauge is mechanical, but if you go to Walmart, buy some new tire gauges, tire pressure gauge, it's electrical. So inside is solid state pressure sensor. Again, same thing. You build a IC right here on the silicon chip. This silicon chip will just basically measure the pressures. Again, by having a silicon chip, we can build very complicated DSP circuits into it. Also put a display, so you can read out measure the pressures directly on the meter, PSIs. So that's another type which getting more and more popular and common. So those are the pressure sensors. The last type of pressure sensor is is also called a vacuum sensor. So on one side, it's very difficult to measure high pressures. On the other side, if it's extremely low pressure, like a vacuum, also it's kind of difficult to measure extremely low pressure. I actually have one of those vacuum pump. Those vacuum pump is used if you want to draw vacuum on your air conditioner unit. So when you repair your AC, before you charge your AC, you have to use the vacuum pump to completely draw the moisture and the air out of your air conditioning unit before you charge them with freons. So how do you measure the vacuum? There are different gauges, thermocouple gauges. It turned out thermocouple by measuring temperature, because when it's completely vacuum, there's no thermal exchange. There is no conduction. The thermal energy travel by radiation, conductance, and convection, right? That's three-way thermal energy travels. By measuring the temperature, you can measure the vacuum indirectly. That's one way to do it. This is a quite interesting way to do thermal, not thermal, to measure the vacuum by having the the colors. So if the color of your filament match the color of cathode, then they can measure very low pressure very accurately. I'm not familiar with this type, but anyway, that's another alternative if you want to measure vacuum. That's most likely used for accurate scientific experiments when you really want that vacuum measured very accurately. This is one way to do it. So that's the third type, right? The last type will be the flow. Flow sensors, all these sensors are popular. Flow sensors, Craig is talking about, he is changing the augers to change the flow. But ideally, you not only want to change the auger, you want to also put a flow sensor to measure how much is the flow, like a gallon per minute or 2 gallons per minute flow sensor. Craig, do you have a flow sensor in your chemical plant?
No, I just have to go up to a machine in the lab and put a sample in the machine and test how much it flows when it is melting.
Okay, so you just timing your samples. You take a sample for 1 second and then measure. Is that how you measure the flow?
That is correct. Yes, I just do one sample at a time. Okay. Now, I suppose we could try to do something like this, but the difficult thing is the material changes constantly because it's all recycled stuff. So if you get one sample in at 1 hour, it can be completely different from the plastic that comes in the next hour.
Oh yeah.
And the end product is all mixed together, so it's difficult to find measurements on anything without separating them out in individual batches.
Yes, in the real world, there are all kinds of challenges. So let's look at the solid flow sensor. First type flow sensor is a conveyor belt. This is I'm assuming you have the recycled plastic dumped it on conveyor belt. And the flow is measured by this load cell. That is one of the strain sensors. So this strain sensor will measure the weight of from here to here. So it will measure the weight in this weight platform. Weight platform started here, ended there. And by taking the weight, then measure the speed of the conveyor belt. Let's do an example. So a coal conveyor belt moves 100 feet per minute. The weighing platform is 5 feet in length, so 5 feet. And the measure 75 pounds. What is the flow? So all we need to do is put it in the equation. The flow will be 1,500 pounds per minute. So all you need to know is the weight and the speed of conveyor belt. Once you know the speed of your conveyor belt and you know the weight of this load cell measured by the load cell, and you put it together and the length of your load cell, you get the flow rate. That will be 90,000 pounds per hour. So that is something potentially Shenzhou Plastic can put, probably already have one of those. I don't know. So that's a solid flow, solid material flow rate. How about liquid? To measure liquid, like pumping gas. When we pumping gas, obviously we need to measure flow and the flow rate very accurately because that's money we pay. We want accurate, for example, less than 1% or even a fraction of 1%. We want extreme accurate measurement. So how do we measure flow? There are many different ways to measure flow, and we will introduce a couple here. Method number one to measure flow is called a restrictive by restriction. By restricting flow, we will change the pressures on the pipe. And by measuring the pressure differences, we can indirectly find the flow rate. So this is method number one. The author gave 3 examples. So this will be your liquid, can be water, you're pumping water, can be oil or gas. So that's restriction number 1, restriction number 2, restriction number 3. So there are 3 different ways to restrict the flow. It doesn't matter how you restrict the flow. The pressure here will be higher. The pressure here will be, no, pressure here will be lower. Pressure here will be higher. So right at the restricting point, the flow will be faster. When the flow is faster, the pressure will be lower. Just like an airplane, when the air flows faster, it has low pressure. So the airplane will have a lift. Same thing here. The pressure will get lower here, lower here, lower here, higher. So P1 will be higher than P2. How much higher? Depends on the flow. So if your flow is very slow, the pressure difference will be small. If your flow is high, medium, the pressure will be medium. If your flow rate is higher, the pressure difference will be higher. So it's all about the delta P. Based on delta P, we can find the flow. Or based on the flow, we can find the delta P. So in this case, let's do this example. The flow is 20 gallon per minute. So 20 gallon per minute. What is the delta P? 0.03 psi. So if it's 20 gallon per minute, 0.03. What about we increase to 150 gallon per minute? So we significantly increase the flow. The pressure will change to 1.6 psi. So 20 gallon minutes is 0.03 psi, and 150 gallon a minute will be 1.57 psi. And then we change the pressure into voltage. We have a pressure sensor. Output is voltage. The voltage will be 0.05 at 20 gallon minutes, and 2.8 voltage at 150 gallon per minute. So that's most common flow sensor used in the industry, restrictive type. Well, what is the advantage of this? The advantage of this is it's smoother, so this can be used in dirty waters, like a sewer application, sewer lines. You do not want this in the sewer line, this type, because the material, the solid material will be caught, and your sensor will be blocked, and maintenance problem. So there's different types of flow sensor. The second type is also pressure differences, but it's not the restrictive flow. It's called it's actually a tube. So the tube will have a nozzle directly facing the direction flow. So in this case, the PT will be higher than PS. So the differences represent flow. So that's the second type. This tube will also have some restrictive effects, but it's not as restrictive as the previous ones. So it will also restrict flow a little bit, but That's our second type. The third and the fourth can also be called restrictive, but we don't call it restrictive. We call obstruction flow sensor. I don't know why they gave different names. Anyway, obstruction flow sensor. This is number one obstruction flow sensor. It's a rotating vane. The higher the flow, the rotating way. This vane is spring loaded. So the higher the flow, the more rotations. Another will be have a turbine. The higher the flow, the faster the turbine will rotate. The turbine will attach to a tachometer, measure the RPMs of your turbine. So this way, the sensor will read the angle. The sensor will read RPM. By reading the angle, reading the RPM, we can also indirectly measure the flow. The last type the author introduced here is non-restrictive, completely non-restrictive. This is called, this type is a mechanical, not mechanical, magnetic flow sensor. So this is magnetic. This is a perfect choice for sewer application, because for sewer application, there's a zero obstruction, there's a zero restrictions. The sensor works by having a magnetic field. So we are creating a magnetic field. What happens if you have a magnetic field, then you're pumping dirty water through the pipe? When you have a magnetic field, you're pumping dirty water through the pipe, the dirty water became a generator. It will generate electrical power. Not very much, milliwatts, very weak electric voltage. So we can have two sensors attached, two electrodes attached to the left and right. And the faster the dirty water travels, the higher the voltage it will generate. So we will have electrical circuits to measure the voltage. By measuring the voltage, we can have an idea how much the water flow, how fast the water flow. This type of sensor only works for dirty waters. If the water is pure water, drinking water, it doesn't work. Why? Because there's no electrolytes. You need electrolytes, the negative and positive particles inside, negatively charged and positively charged particles. When you're pumping dirty water, the positive charged particle will be pushed one direction. The negative charged particle will push the opposite direction. That is how the voltage is created by motion. So the motion creates a voltage. The voltage will be measured and it represents the speed of your motion. So that's a different type of flow sensor. So come back to the question, what type of flow sensor is used when you're pumping gas? Yes? No?
Well, probably not. There probably isn't any electrolytes in gas.
Yes? Yes? All this.
Probably the pressure difference sensors.
Yeah, that might be. That is for the industry, the oil companies. We used to have students from Saudi. We used to have many students from Saudi. They came to our school to study, and most of them go back work in the oil industry. So they use this type of sensor quite often, measure the flow, because that translates to dollars, right? Another type of flow sensor the author did not cover here. That's my guess. The type of sensor used when we pumping gas. These sensors are called the positive displacement flow sensor. The author did not cover this in this book. Positive. Positive displacement flow sensor. This sensor, this flow sensor, is kind of like the coolant pump. Has anybody work air conditioner? The coolant pump pumping coolant. They have gears. The gears are machined just so much that every time the gear passes, it will push a certain volume of material through the pump. So this is called a positive displacement pump. Or if it's used as a sensor, it will be called a positive displacement sensor. So, so they have gears machined. So when the gear rotates, every time it rotates one rotation, it will pump fixed amount of volumes through the gears. Positive displacement flow sensors. That is the kind of sensor I guess, will behind the gas pump. So it will push a fixed volume through the pump. But I'm not completely 100% sure. So maybe some of you have more experience and can tell us what kind of sensor you use when we pumping gas. All right, that's all we want to talk about today. Any comments before we stop our recording?
I kind of have a question because at my job, there's like, if we need to add, for example, if we need to add water to a system, we open up the valve for the pipe that has water, but say we want to add a certain amount, like 500 gallons of water or something. We have a flow meter there, or a counter that we would type in. It's digital, and you would type in like 500 gallons and set it, and then it would close the valve after it reached 500 gallons.
Yes.
But it's not necessarily measuring the rate of flow because
measuring volumes. Yeah.
Sometimes it can take longer, depending on the flow rate. It can take longer to get that 500 gallons, or it could be faster depending on what the pressure is at.
Yes, that sensor may be positive displacement flow sensor. You're pumping through a set of mechanical gear, and every rotation, the fixed amount of volume is pushed through.
Okay.
Also, by measuring flow rate, the digital circuit can calculate the volume.
Okay.
So once you have the flow rate, the computer will do integration. That's your volume. So volume can be calculated by computer once you know how fast you are pumping in real time. That's an excellent example. Actually, let me give you one more example. I was in China last year, every summer. In China, every meter is exactly like what you said, Tim. It's prepaid meter. So we prepay certain amount of water, and the meter will shut off when it reaches that amount we paid. We have to pay them to let the meter turn down. It's all wireless technology. So the meter will automatically shut off when we run out of our prepaid volume. And then you use your cell phone to pay the water company. I want to buy 100 tons. And instantly your payment goes through. And that meter will get the cell phone signal, and that meter will put 100 tons of water credit right into that meter, and now you get water again.
Okay.
Water and electric, they all work this way in the apartments in China. Yeah.
So you do not pay at the end of the month?
No, prepaid, everything prepaid. You just prepay certain amount. You don't have a monthly bill. You just pay however how much you want to use. And once you use up, you have to, on your cell phone app, you just pay them again by a certain amount. And then cell phones, yeah. So it's completely digital. Yeah. Yes.
What happens if you put in too much?
Yeah. Yeah, you just gauge how much you could use. For example, you just buy 100 ton every time. So if you pay 100 ton, you don't use it, it's just there. The credit will be always there.
Yeah, you could go through the whole amount in 1 month, or it could take you a month and a half to go through that amount. But when it runs out, just buy it again. It's not a month to month.
Yeah, not a month bill. Yeah, the credit will never expire. Yes.
Okay, well that's cool.
Yeah, that's my father. My father had that apartment. They update meter all the apartments. So one apartment, my father only lives there during the summer, right? So he just pay whatever water he need to use. Yeah, and everything goes through cell phone. And that's which app they use to pay their telephone bill, water bill, electricity bill, every bill. That's the app President Trump, our president, trying to block. It's called WeChat. That's WeChat. Everything goes through WeChat in China. It's 100% control. Your life it depends on WeChat. That's WeChat. If you never use WeChat, that's WeChat. And right here, you pay your water bill right here. That's payment. Every payment. I can actually pay my father's water bill right here in real time. I pay 100 renminbi or $10 water bill for my father, for example. Cell phone bills. I can do anything. Buy tickets, call food. I can call food delivery to my father. I actually bought my father groceries. Very often, I will buy my father groceries using this app. And President Trump says they will block this app. So if they block it, I will never be able to buy groceries to my father. So that's why we are so much against it, because we are just trying to buy my father groceries. Yeah, it's a interesting app. If you're not living in China, you never use it.
So there's no way for an American to just get that app and use it?
Yes, you can download and use it. They were supposed to block, but the block was blocked by the judge. So Trump said you can't use it, but the judge says no. You can use it. So now it's still fighting, legal fighting is still going on. But now it's still legal to use this app. Actually, it's I don't know. But if you're not living in China, you don't really need to use this app.
Okay.
Yes, last summer when I was in China, I go completely cashless. I didn't spend any cash. I spent maybe $2,000 during that month with my father. Every cent is spent through that app. Buy grocery, buy travel, buy hotel room, buy train tickets, buy delivery, pay bills, everything. Even the beggar on the street use that app to get the little exchange. And nobody use cash in China right now. So if you even the small farmers sell their product, everything, every transaction goes through. If you take a cab, they don't take cash. If you pay the cab driver cash, the cab driver will become suspicious of you. Why you are paying cash? Because cab drivers do not want cash in their cab. They don't want cash.
Okay.
Yeah, it's unbelievable. China do not have credit cards, so we go from cash to cashless in that route to cell phone. So cell phone became so important. All you need is cell phone. You don't need a. In US, similar thing, but the US is a credit card. So we became a credit card society. Actually, last time I went to pumping gas, buy gas, I forgot the credit card, I forgot wallet, I forgot cell phone, I forgot everything. And then I realized I have my Apple Watch. So I actually paid my gas using Apple Watch. That makes me excited, yeah. $40 gas paid by Apple Watch, right there at the pump. Cashless is so good. I always think every time somebody wants a $1 tip or $2 tip, I don't have a dollar bill. Anyway, anything else? We really need to stop the recording. Okay.